Now, we are starting with 2.8. Okay, so we skipped 2.7. I think this book has it wrong, and they have it out of order, so we're going to do 2.8, 2.9, and then go back to 2.7. Okay? I think this book is wrong, so this is a better order. So, 2.8, we are talking about similar figures. Similar figures have same shape, but different size. And if they are similar figures, they have congruent side ratios. All right, so the first thing I want to talk about talking about these is triangle. I have a big triangle and I have a little triangle. Ta-da! All right. If my first triangle is labeled A, B, and C, and my second triangle is labeled D, E, and F, we can compare the sides of the triangles that are in the same place. Okay? They are a ratio that's compared. So if we decide to go big over small, we got to do all of them the same way. So first we're going to talk about the sides. We would do from one corner, one vertex to the other. So we would say AB is proportional to DE. And since they are similar, the symbol that goes in between is a little wave. Now let's do the next side of the triangle. If I go from BC, what side of my little triangle is in the same place? EF. Exactly. Okay, then the next one, if I said I went from C to A, what do you think my other triangle would be? F to D. Very good. So the sides are similar. That's where similar figures come from. However, the angles are equal. So now we're going to talk about the angles. Yes. Are congruent. It helps if I can spell congruent. That's not even close. There we go. All right. So when we're talking about angles, the symbol for an angle, that's an angle, and you put like a little curl in it. Okay? So angle A is going to be equal to angle D. So this angle right here is equal to this angle right here.
So how do you figure that out?
They're in the exact same place.
So you could have a wonky donkey looking triangle and that triangle, but if their letters are still in the same place,
no, their sides have to be proportional. Yeah, their angles have to be equal for it to be similar.
How do I tell that? So like that.
Okay. All right, the next angle. We're going to do angle B. Angle B is going to be equal to what angle in our smaller triangle? E. Very good. Angle B is equal to angle E. Then I have angle C is equal to angle F. Very good. So what you are doing right here is what you have to do for the very first problem in your homework, number 6. Okay? You have to do the sides and you have to do the angles. Is there any question? No. So we're clear here? Okay. Now the whole idea is we can take these proportions and in order to find a missing side, we can set it up as ratios comparing the sides, which I know you did last year, right? So, to find missing side. 1, we're going to set up 2 ratios, and then we are going to cross multiply. So let's say I have, here's my one triangle. We'll make it a little different. And here's my other triangle. So I have side 8 over here, and on this one I have, let's say, a 5. And the bottom of my big triangle is, let's say, 12. And I want to know what the bottom of the other triangle is. So we're going to set up the sides proportional. You have to set them up the same. So I like us to go the big triangle over the little triangle. All right? So we're going to take the big triangle, this side, which is 8, over the little triangle, the same side, which is 5. Equals. Because they have to be the same ratio, the same proportion. Then I'm going to take the big triangle on the bottom, which is 12, over the little triangle on the bottom, which is the unknown side, which is x. Is there any question how I just set that up? Now we cross multiply. I like to multiply the direction of x first. So 8 times x is 8x equal 5 times 12. And then what do we do? Perfect. X equals 7.5. Good. All right. Okay. Example number 1. We already talked about what you have to do for the first problem. So the next section, 8 through 12, it's find the missing side. And let's say I have do 10, 4, let's go x, and 5 over here. All right. So again, we're going to set up the same sides we know, right? We know they both have the bottom of that triangle. So we're going to start by writing 10 over what? 4. Good. 10 over 4 equals. Careful. The big triangle over the little. It's got to stay the same. X over 5. Right? We did the big one over the little one. And both proportions have to be set up the same. Now we go ahead and cross multiply. 4 times x is 4x. 5 times 10 is 50. Good. X equals 12.5. Is there any question on how to do these? All right, so let's move on then, right? We don't need more examples of this. All right, so the next section we're going to talk about scale. Scale, guys. Scale compares the size of a model to real. I'm going to say it that way. So sometimes it's a map to the real side of Earth. Sometimes it's a model, like a model car to a real-size car, or a model airplane. Or sometimes it's the model of a building, right, for the real building. Those are all scales. And how they compare them is what we are going to use to actually find the size of what we want everything to be. Okay? So in example number 2, I'm going to tell you that the scale of a map is 1 centimeter is equal to let's say 20 kilometers. How far is 3.5 centimeters? Okay, so we're actually going to use our scale that we're given for our first ratio. We're going to take 1 centimeter, so I'm putting centimeters over kilometers. So I have 1 over 20 equals. Now I know the centimeters, 3.5, but I don't know the kilometers. So centimeters has to go on top, 3.5 over x. Very good. All right, just a second. So now we cross multiply. 1 times x is x. And 20 times 3.5 is what, Austin? What is it? 70. I agree. Yes, good job. All right. So, on problems 14 through 16, or 14 and 16, that's all you have to do. They're going to give you the scale. They're going to give you centimeters. You got to find it in kilometers. All right? Right? Okay, example number 3. The scale of a model airplane is 1 inch is 10 feet. If the real plane has a wingspan of, what do you think, 50 feet? Yeah. 50 feet. 50 feet. How big is the model? All right. So, first of all, our first proportion is the scale that we're given. So we have 1 inch is 10 feet. So we have inches over feet. Or you can say this, the model over the real one, right? So then if I know the real wingspan is 50 feet, does that go on the top or the bottom? On the bottom. So I have 50 on the bottom. My unknown goes on the top. Good. 10x does equal 50. Very good. X equals 5. All right. So you have a couple of these where they actually give it to you in a model. All right. Okay. Same deal, right? Good. All right. Last one I want to talk about is a question that we always end up getting, I always get back, so I want to just touch on it. Example number 4. All right, this is number 18, or similar to number 18. So use your notes when you're working on your homework today. Okay, this is similar. We're going to say bad X and ugly are, oh goodness, 15 miles apart. That's not true, but we're using it anyway. On a map, the distance is 1 inch. Now let's say 2 inches. 2 inches. 2 inches. Sorry. Find the scale. So when you're using a scale, it has to be a single for the first one, right? It's always like 1 centimeter equals, 1 inch equals. Well, this is in 2 inches. So what do you think we have to do with these two numbers? We have to divide them, exactly. So we're going to divide. 15 divided by 2 gives us 7.5. So this is going to be 1 inch to 7.5 miles. That's all you have to do. Just divide them and rewrite it.
Are we double? No.
Are we going to work or should I keep talking? Okay. All right. So today, you are on page 134, 6 to 38 even. I want all of you to get started so I can walk around and answer questions. Because I have a few, I'm sure there's going to be a few questions on the first one. And there'll be a few questions later on a couple other ones. So I want to make sure I'm clarifying things. All right. So go ahead and get started. And let me help you, my dear.